class. Sorry I can't be there today. I just wanted to record this in case you wanted some extra practice for some review. So let's start by graphing inequalities. So remember we graph the inequalities less than or greater than with just an open circle because those show that the point is not included. So if you're graphing with a less than or a greater than, you're going to have an open circle. And then for less than or equal to or greater than or equal to, you're going to have a closed circle. And then you're going to graph for the numbers that fall into the solution set. So the first example says that x is greater than or equal to -5. So since it's equal to, we're going to have a closed circle. And then the numbers that are true for x being greater than or equal to -5, or the numbers that are greater than or equal to number 5 fall to the right of -5. So we're going to graph our inequality to the right. We have an OR inequality. So this one has two parts. Our first set is for x is less than -2. So it's not including -2, so open circle, because it's not equal to. And then the values that are less than -2 are to the left of -2, like -8. Or x is greater than 4. So 4 is also not included, so open circle. And then the x values that are greater than 4 are to the right. So our OR inequalities always face the separate directions. And then the AND inequality, this one we have to read from the inside, either from left to right or from the inside out. If you read it from the middle, it says that x is greater than or equal to -4 and x is less than 8. Or -4 is less than or equal to x and x is less than 8. So we're going to have 2 points graphed, a closed circle at -4 because it's equal to, an open circle at 8, and then my x's are less or -4 is less than my x's, and x is less than 8. So in the AND inequality, I'm between those two numbers, -4 and 8. Let's try practicing some simple inequalities in word problems. So I have at most $350 to spend on a PlayStation. At most means less than or equal to. So the money that I have is less than or equal to $350. That's as much money that you can spend on the PlayStation. There are less than 50 students participating in the math club. So less than, so students is, less than 50. I have at least 15 collector cards. I like to remember this one like you have to be at least 42 inches to ride on the ride. So anytime I see at least, I think about that. So at least means greater than or equal to because you have to be taller. So I have at least 15 collector cards. So the number of cards that I have is greater than or equal to 15. These ones are compound inequalities. So my sister is older than 20, but is younger than 25. So that means she's between 20 and 25 years old. So this time I would put like my sister's age. I don't know, I'll just use X for this one. She's younger than 25, but then she is older than 20. You could also write this as an AND inequality, like X is greater than 20 and X is less than 25. So compound written together, remember the inequalities always point to the smaller value. X goes in the middle. They always point the same direction. And younger and older were both like less than and greater than, not equal to. A price of twin homes start at $120,000, but they are all under $250,000. So this is an in-between one again. This time, since it says it starts at, that means it can be equal to, but they're all under 250, and under just means less than. So the price is less than 250,000, but they're all starting at, so greater than or equal to 120,000. Notice that this says it's between these two prices then. We start at this price, it's less than my price for my homes, and then that price is less than 250,000. So the inequalities are both facing the same direction again. In my apartment, I can have no more than 5 animals, and I want at least 1. So no more than 5 means less than or equal to 5, but you want at least 1 is greater than or equal to 1. So the number of animals that you can have has to be less than or equal to 5, but greater than or equal to 1. What is the difference between the 3 inequality statements, and which one represents this inequality, that A is greater than 12 and A is less than 17? The person is at least 12 years old but younger than 17. The person is older than 12 but is younger than 17, or the person is older than 12 but is 17 years old or younger. The correct answer is B. The reason that it is B is because in A it says at least, and at least means that it would be younger than 17 but equal to 12. So at least implies equal. A person is older than 12, so greater than 12, but 17 years old or older implies equal to again. So those are the differences in the slight wording, at least and then or younger. So if we have one that has just less than, we need to find the one that contains just the less than or greater than words. Okay, then we practiced writing compound inequalities from a graph. So I'm going to do a couple here for you. So this is an and inequality. Our points, our x's are between 2 and 4 here. So we write this one as x's, they're both closed circles, so it's less than or equal to 4 and then greater than or equal to 2. But we face it, the x in the middle, so we point at the smaller number on both sides. They both face the same direction. We're between 2 and 4. Both closed circles, so both inequalities have an equal to. Here my x's are between -5 and 2. 2 has a closed circle, so less than or equal to 2, and then open circle at 5, pointing the same direction, or at -5, greater than -5. This is an or inequality, so we're going to write this one separately with the or word in the middle. On the left side here, all my x's are less than -2, or my x's are greater than 0. The next thing we did was solved equations for inequalities. So remember, we're using our inverse operations when we're solving. So my first one, I have -4 plus x is greater than 7. So I'm going to start by getting rid of a -4. I'm going to do a +4. I'm going to do that to both sides. So adding 4 to both sides. That's going to leave me with x is greater than 11. And then I'm done. I've gotten my x by itself. So inverse operations, whatever you do to one side, do to the other as well. In this one, we have x divided by 3. That's what this fraction bar means. So to get rid of a divide by 3, I need to multiply both sides by 3. So that will take care of that, and we'll get x greater than 8 times 3 is 24. And then we're done. If I have something like this, it says -5 times x is less than or equal to -50. To undo a multiplication, I need to use division. So I'm going to divide. I want to divide by -5 on both sides. Because not only want to get rid of the 5, I want to get rid of the negative as well, so that I leave x by itself on this side. Then remember our rules of inequalities. If we multiply or divide by a negative number, we need to flip our sign. So instead of less than, it becomes greater than. Then a negative divided by a negative is positive. So 50 divided by 5 is 10. And that would be our answer here. $12 is greater than or equal to 4 plus x. This is similar to the first one. It's a +4, so I will have to subtract 4 from both sides. Would be my inverse operation. So 8, subtracting, you do not change the inequality. It will stay. And then we got x left on this side. But in order to graph this one, if I wanted to graph it, I would rewrite it with the x on the other side. So 8 is greater than x is the same thing as x is less than or equal to 8. So if you flip it around, make sure to flip that inequality again, and that makes it easier to graph. Looks like a little bit of a typo on these ones. These are supposed to be 2 different problems. So first, 2/5 x is greater than 8. We're going to start by solving this one. When we have a fraction next to a variable like this, we're going to multiply by the reciprocal to get rid of the fraction and to leave the variable by itself. I'm going to put 8 over 1. because then over here we multiply across the top, we get 10, multiply across the bottom, you get 10x greater than, multiply across the top, 8 times 5 is 40, 1 times 2 is 2. Then we're going to simplify our fractions. 10 divided by 10 is 1, so we're left with just x greater than 40 divided by 2 is 20. So then that would be our answer there. The other one was x divided by negative 6 is less than 2. So if I wanted to solve this one for x, I would multiply both sides by negative 6 because it's x divided by negative 6. And then 6 divided by 6 is 1, so I'm left with x. Since I multiplied by a negative 6, I have to flip my inequality around. And then 2 times negative 6 is negative 12. So x is greater than negative 12 would be my final answer. One more. 10 is less than 5 times x. So to undo the multiplication, divide by 5. I get 2 is less than x. And then in order to graph this, I would rewrite it as x is greater than 2. It would be an open circle at 2, and I'd be going to the right. All right, I hope that was helpful. I'll see you tomorrow for your test. We'll go over any questions that you have prior to that.